Sanibonani bafundi. Sihlangana futhi namhlanje siqhubekela sagcina khona last week. We're dealing with acid and bases. Last time sakhuluma ngama theories that define acid and a base. We had Arrhenius theory as well as Lorry-Bronsted theory. With Lorry-Bronsted, to an acid it is a proton donor, while a base it's a proton acceptor. And with Arrhenius, the acid it's a substance that ionizes in water to produce hydrogen ion. And a base is a substance that dissociates in water to produce what? A hydroxide ion, the OH minus. So we understand what H plus. H plus, then sine acid. Manje inkinga masikhuluma ionizing in water, kusho ukuthi there is a presence of what? Of amanzi. Then with amanzi and the H plus, so says kunika bani or H3O plus. So when there is a presence of H3O plus, siyazi ukuthi sikhuluma nge-acid. Bese kuba khona base. In terms of base, sikhuluma ngo-OH minus, hydroxide ion. So with the presence of OH minus, siyazi ukuthi there is a base. Right. Beside that, sakhuluma ngama strong acid and strong base. Strong acid is an acid that ionizes completely and to produce high concentration of H3 plus, while a strong base it dissociates completely. Maskuluma ngama weak acid and weak base, they just ionize. A weak acid will ionize partially, while the weak base will dissociate partially to form what? A low concentration of OH minus. This is just a reminder. I learned to science last week. Right. Okunye sakhuluma ngama monoprotic and diprotic acid. Monoprotic acid, the acid lezokhiphela OH plus owodwa, such as HCl, for example. About HCl masikhuluma nge-ionization reaction. HCl uzokhiphela OH plus nobani no Cl minus. So njengoba HCl ukhiphela OH plus owodwa, then this HCl it is a monoprotic acid. Another acid was a diprotic acid. An example was given H2SO4. Masipala ionization reaction. Usinikelo H plus what? SO4 2 minus. Mese siyayibalance le equation. Ama hydrogen awu2 ngala left, so we need to balance the equation. So sibona ukuthi for 1 mole of H2SO4 usikhiphela 2 moles of H plus. So for 1 molecule of H2SO4 we'll have what? 2 hydrogen ions. So that one is a diprotic acid. Mokishwa hydrogen now 3, that will be what? A triprotic acid. Right. Then the other thing, sakuluma gama conjugates. Conjugate acid of a base and a conjugate base of an acid. And we took an example, acetyl NH3 or reactor no HCl was kipelo NH4 plus UCl Cl minus. This one is a base, a weak base. Then a base, a base is a proton acceptor. So how do we see NH3 accepted a proton? Sibona ngama product. Begu NH3 manje sekupenduko banu NH4 kusho ukuthi there is an extra hydrogen. Kusho ukuthi lo NH3 u acceptele hydrogen. That makes it to be what? A base according to bani to Lorry-Bronsted. Ngoba ngokwe Lorry-Bronsted, a base is what? Is a proton acceptor. Right? So this one will be what? Will be a base. Nesikhuluma nge HCl. HCl it is an acid. Ngoba sibona ngala it's HCl, masibuka ngala sekuno Cl minus. There is hydrogen engasekho. This means that lo HCl lo udonatile le hydrogen. By donating the hydrogen ion, that is a proton, kusele bani or Cl minus. So this one will act as an acid. So lokhu kwenza ukuthi masibuka ngala sine reaction ye base ne acid. If this reaction is reversible, singathi ukuthi i-reaction ka-NH4 plus no Cl minus uskiphela NH3 no HCl. So by moving backward or we reverse reaction, right? U-NH4 lona uphenduka bani? NH3. Uphenduka NH3 kusho ukuthini? Bese nama-hydrogen awu-4 sigcina ngani? Ngama-hydrogen awu-3. So this makes u-NH4 to act as what? As an acid. U-Cl minus bongenawo i-hydrogen. Kodwa i-reaction i-reverse reaction isinika bani? HCl. So means that Cl minus accepted in a proton. That makes it what? A base. So sibona ukuthi lo Cl minus uvela kulo HCl. Kanti lo HCl is an acid while the Cl minus act what? As a base. So this one is a conjugate. So njengoba sine acid lana, Cl minus will be what? A conjugate base yaleyo acid. Masibuko NH3 no NH4. NH3 is a base, kodwa ngala sinani NH4. A base ngala NH4 is an acid. So we have what? A conjugate acid of a base. And sati last time, a conjugate acid will be from a base, while an acid will have what? A conjugate base. You can always have a conjugate acid of a base and a conjugate base of an acid. Sapinda sakhuluma nge-strength of the conjugate acid or base. Sathi i-conjugate acid ye strong base is weak. I-conjugate base ye strong acid is also weak. So makuthi sine base a strong, mase sibuka i-conjugate yakhona. I-conjugate of a base will be what? An acid. Leyo conjugate acid leyo will be what? A weak acid ngoba iphuma ku strong base. So my iphuma weak base nakhona conjugate acid yakhona will be what? Will be strong, right? Like for example here to NH3, it's a weak base. So NH4 ngoba i-conjugate acid yale base, i-conjugate acid ye strong base, so the acid will be what? No, a weak base, the acid will be what? A strong acid. The conjugate is a strong acid. The same thing applies to HCl. It is a strong acid. So a conjugate base here will be what? A weak base, right? Yeah, that is just a reminder. Sakhuluma futhi nge substance ebizwa ngani nge-ampholyte. Ampholyte, a substance that can act what? As an acid or a base, depending on which other substance reacta ngayo. So inga reacta as an acid, mawuthi reacta ngani nge-base, noma inga act as a base if you react it ngani nge-acid. And some examples of ampholyte, just quickly. H2O was one of them. It acts as an ampholyte. So no HSO4 minus, that was can also be what? An ampholyte. Singaba no HCO3 minus, that can also act as an ampholyte, and so on. So you have different examples of what ama ampholyte. Maskuluma nge-ampholyte ubona H2O, so unama possibilities awu-2. Ingaba i-proton donor, mabu i-proton donor kuzosala bani OH minus, lana kusho ukuthi acta as i-acid. Ingaba i-proton acceptor, mabu i-proton acceptor kusho ukuthi izoba no H3O plus. In that case it acts as what? As a base. The same thing applies kulo HSO4 minus. Kungenzeka abe i-proton donor. Maku i-proton donor, that becomes what? An acid. So kuzosala bani SO4 2 minus. Kungenzeka futhi act as a base. As a base it will be what? A proton acceptor. So izothola omunye hydrogen, that will be H2SO4. Right? That's how a ampholyte will always react. Right? Then okunye sakhuluma ngani acid ionization constant of an acid, right? Asibuke lo HCl futhi in our example, ngoba sithini, an acid is a substance that will ionize in water. This time si react ngani ngamanzi, H2O, lokhu kuskiphela bani or H3O plus plus what, plus Cl minus. Let's put ama phases. HCl is an aqueous solution, H2 liquid, lana to AQ, and OCl minus now ban AQ. Right, into siyazi yokuthi le reaction is over reversible ngoba H3O plus sithe acta as an acid, OCl minus will act as a base. Kusho ukuthi lo H3O plus ungakwazi ukureacta no Cl minus, baskiphele bani o H2O no Cl minus. Kusho ukuthi le reaction lena irreversible. Multi reaction irreversible and sine concentration sine volume engashinji, kusho ukuthi we are almost in a closed system. Masiku closed system and the reaction is reversible, siyakwazi ucalculate i-Kc ngoba le reaction kungenzeka figure to a state where the rate of forward reaction ilingana ne rate of reverse reaction. So mawukuthi kune equilibrium engenzeka kusho ukuthi usinga calculate Kc, right? So in that case asitukubhala Kc expression kule equation, sikhala ngama products kone concentration ka H3O plus ngoba ku aqueous times concentration ka bani ka Cl minus over, right? Now siyayibuka lento lana sino HCl concentration ka HCl mase kuno H2O. Remember ngesikhathi sicalculator i-Kc sithe asifake ama liquid nama solid, so siyawuyeka lo H2O ngoba ukwi liquid state. So when you look at this, significance ka Kc izothini ngoba sikhuluma nge acid, kusho ukuthi ngoba sikhuluma nge acid, instead of writing Kc singathi ubani uKa ubizwa ngani ionization constant, right? Ye acid ionization constant. Sazi nge Kc sazi ukuthi when you have a greater value of Kc, it simply means that ama product maningi kwi container compare kuma reactant. So when you have a high Ka, this simply means ukuthi sinama H3O plus and Cl abaningi, and can H3O plus wona wenza ukuthi sibe nani ne acid. This simply means that the higher the Ka, the stronger the acid, right? High Ka means what? A strong acid. This simply means that any strong acid, let's say define ukuthi it's an acid that ionizes completely, right? Will be what? Any strong acid will have what? A high Ka. Ionization constant. If the Ka is low, then we have what? A weak acid. The weak acid such as oxalic acid, acetic acid, carbonic acid, bonke labanan, bano Ka omncane. Then that is the ionization constant of an acid. As khuluma nge base, so the example we can take for the base, asebenzise NH3 futhi. NH3 reactor namanzi, then siyazi ukuthi it's aqueous solution, amanzi futhi liquid phase. Then sino NH4 plus what? Plus OH minus. All of them here are what? Ama aqueous solutions. That we have aqueous solutions. Right now, it's also an aqueous solution. So if this reaction is reversible, ngoba OH minus uzo reactant, and remember NH4 will act as a acid, OH minus will act as a base. So this reaction is also reversible. It means we can reach equilibrium. And at equilibrium, the rate of forward reaction is equal to the rate of the reverse reaction. So we can also calculate bani Ukc work on at a certain given temperature anyway. Then we have the concentration ga NH4 plus times what? Concentration ka OH minus. Then on the denominator, sine concentration ka NH3 pen. H2O siyamshia ngoba u liquid state. So again, ngoba sikhuluma nge-base so beza bani uKb. That is what? A dissociation. Ngoba sitenge base i-base ya dissociator in water to give you what? OH minus. A dissociation reaction a dissociation constant ngoba sikhuluma nge equilibrium constant. So that is the Kb. It simply means that if you have a high Kb, if value Kb is high, which simply means what? We have what? A strong base. So I'm a strong base akniga banu Kb omkulu. Right. Then the next thing is sokuluma ngayo, it's when sidila ne ampholyte. Say ampholyte is a substance that can act as an acid or a base. Now, ampholyte sokuluma ngayo ngala sokuluma ngamanzi because water was part of ama ampholyte. This simply means that water can react with water, right? Water can react with water, right? Ngoba we ampholyte so kungenzeka lona abe acid lo abe a base. So in that case, uma lo H2O will react as an acid, it will be what? A proton donor. Must denote le hydrogen, it will remain what? OH minus, right? Aqueous then plus low H2O also act as now act as an acid, now act as a base, and if base has a base, it's a proton acceptor. So when it accepts a proton, it becomes what? H3O, H3O plus, right? Again, sazuguti OH minus no H3O plus kunga react kuskipele banu H2O. So this reaction is also what? A reversible reaction. Again, ngoba sine reversible reaction singa figure to a point where a rate of forward reaction ilingana ni rate of a reverse reaction. In that case, we can reach what? Equilibrium. Kandimasine equilibrium siyawazi calculator ini equilibrium constant. So at this point, equilibrium constant expression is over in OH minus concentration ka OH minus times concentration ka bani ka 3H3O plus over masibu angala kuma reactant. The first H2O, it's liquid, so share panti. H2O also a liquid, so will be what? Over 1. On the side of ama reactant, there is no aqueous or gaseous what substance. So this is what 1 over 1. Ngoba lo KC lo hamsana na mass, so we call it what? The auto-ionization. This is the auto-ionization or self-ionization of water. Amanzi can ionize itself, right? Ionization of water. Ngoba sikhuluma nge auto-ionization. Lo KC asimbize ngibani? UKW. So sibona ukuthi by KW is simply what? A product. Ka concentration ama OH minus times what? A concentration ka H3O plus. Ini fanele sinagelana ukuthi OH minus usitshela ngani nge base kanti H3O plus usitshela ngani nge acid. Right? Now, ngoba says the only factor that can affect the equilibrium constant is temperature. Remember the Gescatis kulumange equilibrium. Say the only factor that can affect what equilibrium constant is what is the temperature. So if you have a fixed temperature, no KW wako uzoba umazi. So at room temperature, it's what is 25. Room temperature, it's what is 25 degrees Celsius. So at 25 degrees Celsius, it was found that lo KW, mabem calculator, KW, uskipela bani 1 times 10 to the power negative bani, negative 14. That is the value of the Kc, low Kw, when we are at room temperature. And into siyaziyo ukuthi lo Kw siwuthole ngokuthi senza ama concentration, the product of ama concentration. So Kw was what? A concentration ka OH minus times the concentration ka bani H3O plus. And still a product at room temperature, it gives us what? 1 times 10 to the power negative 14. Logo ukwenza ukuthi siyakwazi now ukurelate ama concentrations. Lawa ama concentration OH minus no H3O plus, they can be related mathematically. So masibuga le formula len. So the concentration ga OH minus matu siyayifuna singati 1 times 10 to the power negative 14 divided by what? A concentration ga H3O plus. Please remember that. Then from the same formula we can deduce what? The formula for what? H3O plus in terms of OH minus. So singati concentration ka H3O plus, right, will simply be equal to 1 times 10 to the power negative 14 over a concentration ka OH minus. This simply means that uma siyazi concentration ka OH minus yakwazi ukuthola i concentration ka bani ka HO plus, H3O plus, right? Now let's take just one example here, right? So that we have to do the application of this equilibrium constant of the self-ionization of water, right? Let's say tiwa the concentration of H3O plus in a solution is what? Is, let's say, is 0.02 mole per decimeter cube. So the concentration ga H3O plus in a solution or 0.02 mole per decimeter cube. But to calculate a concentration, calculate the concentration ka OH minus, right? So what do we know is that goba sine concentration ga H3O plus, the concentration ga OH minus ilo sifuna, it means we can actually get easily the concentration. So by from the formula, sazuguti a concentration ga OH minus times the concentration ga H3O plus, uskipela ban 1 times 10 to the power negative 14. So njengoba sifuna OH minus, so the concentration ga OH minus, it's what? 1 times 10 to the power negative 14. This divided by a concentration ga H3O plus. Ngoba sinigezwe le concentration ga H3O plus. So masenza ama substitutions. From ama substitutions, from this question, uzosinika 1 times 10 to the power negative 14 divide a concentration H3O plus nigezwe ona 0.02. So if I go 0.02 mole per decimeter cube. My static calculator, then we have 1 times 10 to the power negative 14. So I divide on 0.02. Then sinobani 5 times 10 to the power negative 13. 5 times 10 to the power negative 13. Hiyo le concentration yani OH minus. So you can always mautu nigezwe concentration ga H3O plus, you can always find what? A concentration ga OH minus. No mama nigezwe concentration ga OH minus, you have ukuthola concentration ga H3O plus. Right. Now the one thing we have to talk about today is what? pH. Situkhuluma nge-pH. Last time sistazothi pH a scale. The pH scale is a set of numbers that are ranging from 0 to 14 that indicate what the acidity or how a substance is acidic or basic. So a pH scale is set of numbers ranging from 0 to 14 that indicate how acidic or basic a substance is. And for the pH here, Moktiwa calculate a pH sebenzisa le formula is the pH is equal to minus log ma concentration gabani H3O plus, right? Now in other textbooks, you are going to pH is the same thing. pH is minus log of OH plus pen. It's fine. The same thing. More the formula of this one is the same thing. Remember, the H3O plus ukamuga kwi definition ga arrhenius suguti the acid will ionize in water. Skipele labo H plus. So malo H plus reactor na manzi uskipela H3O plus. So sa inte yoto mo tuzo sevensa le formula. Right. The other thing you need to know, in case we question or unigezwa mhlambe pH mase kuthiwa calculate I concentration ga H3O plus noma concentration ga OH minus, something like that. The formula uzoyisebenzisa is the anti-log. Angisiloku kwi log. So the anti-log we calculate ukuthi H3O plus is equal to what? 10 to the power minus of pH. Right? So just take 10 to the power pH. Let's say unigezwa ukuthi pH of a solution is 2. Right? Just an example. So mafuni concentration kabani H3O plus uzoti 10 to the power negative 2. And then you get what? The H3O plus. That is all for this pH calculation. Asiti kwenza nje isibalo soto so that we are sure ukuthi I see understand kahle lento. Right. Calculate the pH. Calculate the pH of 375 centimeter cube, right? Solution of made of 2.5 grams of what? Of HCl. Right. Now, sinombuzo lana uthi calculate the pH. Into siyaziyo ukuthi i-pH si calculator as sebenzisa minus log kabani H3O plus. But looking at the example here, asi now H3O plus sinikezona but sine acid. Siyabona ukuthi sine acid la. Right? And siyazi ukuthi acid izoskipela labo H3O plus. So what we need to know first, ngoba sikhuluma nge-concentration. So sidinga ukuthola i-concentration kabani ka HCl. Right. What do we have in terms of low HCl wakhona sinikezwa mani i-mass. So from the mass, how can we get a concentration? So siyazi ukuthi from the mass singathola number of moles, then from the number of moles singathola any concentration ngoba i-volume nayo sinikezwe yona S375. So singatini, the first step is calculate the number of moles. That is molar mass, the mass over the molar mass. From our statement, the mass is what? 2.5. The molar mass ka HCl. So from the periodic table, a hydrogen in a molar mass ka 1 and chlorine is 35.5. So the total is 36.5. So loku kuskipela 0.068 mole. That is the number of moles of HCl found in what? In 2.5 grams. Right. Now, into sifunayo it's what? A concentration. Now, sin the number of moles, then sinani futhi a volume. So from a concentration, siyazuthi concentration is calculated as number of moles over the volume. So a number of moles sinayo 0.068 divided by a volume. Now, the other thing if I say as if a concentration, a unit a concentration, it's mole per decimeter cube. Koto alana basniga bani ama cubic centimeter. So the first thing is to convert 375 centimeter cube into what? Into decimeter cube. Si divider 1000. Masi divider 1000 is uskipela 0.375. Right. So answer yetu is over 0.375 sino 0,068 divided by 0,375. Lokhu sikuphela 0,181. Round off 3 decimal places. 0,181 mole per decimeter cube. Ngoba calculator in concentration. Right. Now here comes the main issue. Angithi le concentration, it's a concentration ngabani ga HCl. So singathi HCl, concentration ga HCl is 0,181 mole per decimeter cube. Umbuzo uthe calculate the pH. Into sifuna a concentration ga H3O+. So ngoba sine concentration ga HCl, kuyaphoqa ukuthi senze ionization reaction ga HCl. Khona sokwazi ukuthi ithini ratio between HCl nalama hydrogen ion izowakhipha. Right, remember futhi HCl, it is what? A monoprotic acid. Labo kusho ukuthi sikephela H+ owodwa. So by writing HCl, HCl uzokhiphela H+ plus what? Cl minus. From le equation le sibona ukuthi I ratio between HCl no H+, it's 1:1. Kusho ukuthi I concentration ka HCl iyalingana ne concentration ka bani? Ka H+. Kanti lo H+ imfunayo for a calculation ye pH. Right? Now, sesino HCl minus and sinani sino H+. And from a equation sithola ukuthi I concentration ka HCl is 0,181. Njengoba I ratio ithi 1:1 or HCl is a monoprotic acid. Kusho ukuthi ne concentration ka H+ uzoskhiphela na uzoba 0,181 mole per decimeter cube. Njengoba sina concentration ka H+, then singa calculator in pH. Ngoba pH yona si calculator as pH is equal to minus log a concentration ka bani ka H+. Sesiyamazi phela H+ ngoba simthole from a concentration ka HCl. So from this one we'll have minus log, so a concentration is bani 0,181. So my calculator, so the minus log from your calculator, minus log of 0,181. Spell abani 0,74. 0,74. Ngoba ku pH vele siyazi ukuthi asi writing ala. Cause enye into efanele iguide ukuthi siyazi ukuthi acid, pH acid is what? Is between 0 but less than 7. Njengoba solo to 0,74 asi write lapho, and from HCl siyazi ukuthi it's a strong acid. So I number sitholayo ihambisana kahle ne concept yethu. So we have 0,74. Right. One more thing I want to emphasize on. What if the acid was a diprotic acid? A diprotic acid. Angisikhuluma nge concentration of 0,181. What if instead of HCl mhlambe sino H2SO4? Sino H2SO4. Right? Asibona ukuthi pH is also calculator kanjani. Ngoba sithola bani, let's say sine concentration ka H2SO4 elingana nalo 0,181 mole per decimeter cube. Umbuzo usathi calculate in a concentration a pH. Right? So the first thing again, fanele senze njani? Sibhale ionization reaction. H2SO4 uskhiphela in H+ plus what? SO4 2 minus. Then the equation has to be balanced. Sinama hydrogen awu2 ngala kusho ukuthi sifaka u2 na. So from this sibona ukuthi I ratio between H2SO4 no H+, it's 1:2. Kusho ukuthi I concentration yama hydrogen ion is twice the concentration ka H2SO4. Njengoba sitholo I concentration ka H2SO4, right? Masiqhathanisa ne concentration ka H+, we simply mean that a concentration ka H2SO4 is half ngoba sino 2 ngala sino 1 ngala. So this simply means that i-concentration ka H2SO4 it's just half i-concentration ka bani ka H plus. Noma singathini i-concentration ka H plus is twice i-concentration ka bani ka H2SO4. Why senza kanjalo? Ngoba H2SO4 is what? A diprotic acid. Right? So therefore, i-concentration ka H plus esizoyisebenzisa will be what? 2 times 0,181. And that will give us what? 0,181 times 2. 0,362 mole per decimeter cube. Right? Angithi masi comparisha a concentration ye HCl yema H plus as from HCl compared to a concentration ga H plus as compared to H2SO4. Ngoba HCl is a monoprotic acid, a concentration it is 0,181. Kandi with H2SO4, the concentration is a double of it, 0,362. So just remember every time when you have to look at OH plus, every time write down a ionization reaction. So calculate kanjalo pH yani ye acid. What if now you have to calculate a pH ye base? What if you have to calculate the pH of a base? Right. Now, let's take another example. In a pH a base is we calculate the pH. Right. Calculate the pH of that is solution lana of sodium hydroxide solution, right, of concentration of a concentration started 2 times 10 to the power negative 3, right, mole per decimeter cube. Right. Now to calculate a pH, a base. The base that we are given here ubani sodium hydroxide. Right. Then siyazi ukuthi masicalculate pH, pH uhambisana nani? pH is minus log of what? Concentration ka H plus. Now the problem is this one is a base. This one is a base. So sizothatha lo H plus ngoba i-base siyazi ukuthi base isikhiphela bani? Isikhiphela OH minus. So what we have to do, ngoba sine concentration ka 2 times 10 to the power negative 3 mole per decimeter cube. I concentration ka sodium hydroxide. Kufanele senze njani? Siphinde sibhale dissociation reaction. Uthi lo sodium hydroxide uzoskiphela i-sodium ion plus what? OH minus. Then masibuki i-ratio. It simply means that ratio between sodium hydroxide and OH minus, it's what? It's 1:1. So kusho ukuthi i-concentration ka sodium hydroxide ilingana nani? The concentration ka OH minus. Right, and i-concentration ka sodium hydroxide bese sinikezwe wona, it's 2 times 10 to the power negative 3. So this will be 2 times 10 to the power negative 3 mole per decimeter cube. So sine concentration ka OH minus. Fanele sikhumbule ukuthi OH minus ungaskiphela bani OH plus. Remember ngesikhathi isicalculator i-concentration equilibrium constant for the auto ionization of water, the Kw. Right? Sitheni ukuthi OH minus times the concentration ka H plus basinika 1 times 10 to the power negative 14. Right, now uyabona ukuthi from OH minus siyakwazi ukuthola lo H plus esimdingayo for i-calculation pH. So in our example here, so to OH plus is now equal to 1 times 10 to the power negative 14 over a concentration ka OH minus. And that will be 1 times 10 to the power negative 14 over OH minus, concentration of OH minus or 2 times 10 to the power negative 3. Asibona ukuthi concentration then izosinika 1 times 10 to the power negative 14 divided by 2 times 10 to the power or negative 3. Negative 3. Right. Sisolaban 5 times 10 to the power negative 12 mole per decimeter cube. Now this one is what concentration ka H plus and sitinga leo concentration leo kuze se calculate a pH, right? So from the base ifanele usebenzise le so step. The first step uthole concentration ngoba une concentration ye base. Now uthole I concentration ye OH minus. Uzokwenza ifanele wenze I dissociation reaction. Uzokwazi how does the number of moles of the base relate to the number of moles of what? Of OH minus. Masunalo OH minus susebenzisa mani ionization of water. Then you will get what? OH plus. Then with the H plus sesingakwazi ucalculate a pH ngoba sine concentration ka H plus. So H plus the pH will be minus log H plus. H plus is 9. So we can now write minus log 5 times 10 to the power negative 12. Right. Then from there, minus log 5 times 10 to the power negative 12. Kusiniga pH kapan 11,330. Right. And okunye kufanele sikucheck ukuthi 11 ngoba sikhuluma ngebase vele silindele ukuthi pH izoba above 7. So ngoba solo 11 then kusho ukuthi yonke into ihamba kahle. So that's how you calculate a pH from an acid or the pH of a base. Njalo fanele ukukhumbule ukuthi the concentration of OH minus times the concentration ka H plus normal H3O plus kiyafana. It is equal to 1 times 10 to the power negative 14. Right. So yeah, a pH calculation sesi right, sesi sorted. Then the next thing first kulumengayo it is the neutralization reaction. Neutralization reaction. A neutralization reaction, it's a reaction between an acid and a base. Goba a acid in neutralizer a base and a base in neutralizer a acid. Right, ngesikhathi umixa i-acid ne a base, i-pH ye-acid yanyuka ngoba u-add i-base and i-pH ye-base iyehla. So most of the time if you have a strong acid and a strong base, at the end uzothola pH yakho ube bani? pH ube u7. Remember sithe for 7, pH of 7, the solution is what? Is neutral. Right. When an acid reacts with the base, let's in the acid, the reactor and a base, we always have what? Salt and what? And water. Salt and water. This salt here, it has a positive ion and a negative ion. Those positive and negative ion qamuka kwi-acid nakwi-base. So a negative ion qamuka kwi-acid and the positive ion qamuka kwi-base. Remember, a base will release what? OH minus. That will make it to become what? Positive. While a acid will release what? OH plus. That will make it to become what? Negative ion. So we have that one. Now, maskuluma neutralization reaction. Sibuyele kuma indicators. Last time saskuluma ngama indicators. So we can now react a strong acid with a strong base and sati lapo sebenzisa bani bromothymol blue. Right, ngoba I range yakhona is around 6 to 7,6. then masi reactor a strong acid and a weak base. Sidinga a indicator called what? Methyl orange. Goba a pH corner is around 3 to 4,6 around there. Then ma reactor a weak acid and a strong base. A solution yako will be basic. Then sidinga indicator in a pH above 7, and phenolphthalein was used in that case, right? So when we have a neutralization reaction, acid is a neutralizer a base only if a number of moles ayafana in terms of what? The chemical reaction. Let's say sinalo HCl also react nani no NaOH. So in that case, is salted is over is sodium chloride plus what? Plus H2O. So that is this one is a neutralization reaction. Siazamuk balantisa the equation, the ratio is what? Is 1:1. So the only time, let's say we contain no HCl, right? We fago HCl like acid that you put in. Mese u add a base, right? We add a base. Now, by adding the base, you are neutralizing this acid. You are neutralizing the acid. The main purpose angizufuna pH ube 7 so that it is a neutral. Because in a salt la a neutral salt, right? So masi add the base a pH ye acid is onyuka and a pH ye base is wet until kube low 7. Now, when you have this HCl and the NaOH that are reacting, the neutralization will only take place when the number of moles of the acid is exactly equal to the number of moles of the base from the equation. Goba equation iti the ratio is what? Is 1:1. Ngesikhathi add the base ngalan. Let's say ngikala ngo 0.5 mole one we acid. So in neutralization is only if add abani 0.5 mole of the base. Otherwise, if the number of moles of base is less than 0.5, let's say add the base number of moles lambe 0.4, and so the solution is not neutral. We still have more acid, so it's still what? Acidic. No mamangi add 0.7. Saying a day base ningi kune acid, so its solution is no longer neutral. It's a basic solution. So kufanele ngenze njani ngi-add the exact amount. So i technique izokusiza lapho sibiza ngani nge-titration. Sibiza ngani nge-titration. I-titration izosiza ukuthi sikwazi uku-add the exact amount of the base noma i-acid ukuze si neutralize exactly in the solution esinayo, whether the acid or the base. So sebenzisa in a titration. The titration is usually sebenzisa the technique to get what we're gonna use a concentration of an acid, normal a base that we have to get a concentration of a base on an acid that is unknown. So if we have a concentration, a solution, esiyaziyo in a concentration engine, leo solution sibiza ngani? Sibiza nge standard solution. So kufanele sebenzise in standard solution, right? A standard solution, it is a solution of precisely known concentration. A standard solution, it's what? A solution of precisely known concentration. So mone solution uyazi concentration yayo, then leo a solution ubiza ngani nge standard solution. So uzosebenzisa leo standard solution ukuze uthole i concentration yenye solution ungazi a concentration yayo, and that is what that will be a titration, right? Now, how do you also know ukuthi ayisengi the base enough ezoba exactly leyo amount engiyifunayo? Yabona mangwenza i reaction we are add i base, how will you know ukuthi okay sengi i base ekufanele ukuthi ngiyi add lana? Into ezokusiza ini indicator, uzofaka i-indicator. So fanele ukwazi nawe ukhetha a suitable indicator ngoba the first thing fanele ucheck ukuthi i-reactor i-acid enjani. In our example, i-acid is a strong acid, i-base it's also a strong base, kusho ukuthi fanele sebenzise ini i-bromothymol blue. So uzofaka a few drops of it bromothymol blue ngala, right? Now ngoba une acid, i-bromothymol blue in an acid, it is what? It red. It is red. No, it is yellow in an acid. So mawufaka i-bromothymol blue, your solution will turn ban uzoba yellow, right? Then so you add in a base. You add a base. So when do you stop? You only stop by the time the solution changes the color. The solution changes the color. It means the indicator elana has changed the color. And when the indicator changes the color, si figure kuleo point ezobizwa ngani the end point. So with titration, sidinga in the end point. The end point is just a point where the indicator changes the color. Indicator changes the color. At that point, you have to stop adding what the base or the acid. And it's in our example, basically add any base we acid. So by the time just a drop of a base changes the color, then sitting we've reached what the end point. At that point, end point, ilapos figure kwi equivalent point. Equivalent point. Equivalent point is just that point where the acid has exactly reacted with what? With the base according to a chemical reaction. General to 1:1. So it means the number of moles of the acid is now equal to the number of moles of the base. Goba a reaction here to it is the 1:1. But if, for example, it's 1:2, it means one of the substances will be twice the other one, right? Like let's say sisebenzisa H2SO4 instead of HCl, reactor nani no NaOH, right? Then locus oskipela is sodium sulfate plus what? Plus H2O. We have that one. Bese fanele senze njani sibalance equation. Sinamana ma sodium au tungala so sifaka u2 right? Masibuka ngala on the reactant side, I ratio itini iti 1:2. So in case hlambe kwi container sifaka 0.5 moles 1 where H2SO4, kusho ukuthi I neutralization izokwenza only when si edileban u1 mole yani ye sodium hydroxide ngobani ngoba I ratio it is 1:2. It means the sodium hydroxide, right, will only neutralize H2SO4 if the number of moles ga sodium hydroxide it's twice lokhu sikuthola ngepi from a balanced chemical equation. So every time mawusebenzisa titration ifanele ubuke ini a balanced equation. If the equation is not balanced, then uzoba nenkinga. Njengoba sikhuluma ngokuthi ifanele sisebenzise number of moles, right, in terms of the ratio, ngoba si add a base as an aqueous solution. Masikhuluma nge-aqueous solution sidila nge-concentration, siphinde sidile ngani ne-volume. Siyazi ukuthi i number of moles is calculated as what? As concentration times the volume, right? Now, njengoba I reaction I change from the balancing of the equation, like in this case, ubani or 1:2 from this equation here. The ratio is 1:2. Kushokuthi mangisebenzisa u0.05 for H2SO4. H2SO4. The number of moles ezodingakala for sodium hydroxide fele ubani 0.1, twice of that one, right? So into so itolo ukuthi mangishinja nje number of moles of the acid, even the number of moles of the base will also change so that we maintain what? A particular ratio. So mangukuthi i number of moles of the acid ngibiza ngo Na, kusho ukuthi concentration ye acid is over Ca ne volume yakhona bo Va, and the number of moles ye base mathi ngibiza ngo Nb, right? So concentration ye base zoti Cb, and then concentration volume ye base zoti Vp. This simply means that mangithatha i-ratio between the number of moles ngoba lokhu vele akushinji from the chemical equation. The ratio will still be what? 1/2. 1:2 according to this one. So even though ngisebenzisa ama number of moles, the ratio lena izongikhiphela bani i-constant ethize. Leyo constant ayishinji. So from the equation here singathini ukuthi the ratio here of the number of moles of the acid to the number of moles of the base ngoba kuyalingana, it means it's Ca times Va over Cb times Vb. Ile formula efanele usebenzise maswenza in titration. So lo uNa umthola kwi balance chemical equation, uNb na uthola kwi balance chemical equation, the stoichiometric coefficient in front of the base. This one, it is in front of the acid. This one is the concentration of the acid. This one is the volume of the acid. The concentration ye base ngala and the volume ye base. So in a equation bazokunika mhlambe I concentration ye acid, bakunika ne volume ye acid, bese bakunika ne volume ye base, bese kuthiwa calculate the concentration of what? Of the base. Right? So you use that example and you'll be okay. Right? So that's how it is. But it's not that necessarily fano usebenzise le formula. Kodwa more understand ukuthi in number of moles I reactor kanjani still is the same thing. So from a concentration ne volume ye acid uyakwazi ukuthola number of moles. Then with the number of moles ubuyela kwi chemical equation uthola ama ratio. With the ratio kuzokunika bani number of moles of what? Of the base. Then ubuyele ngalana futhi ngoba usune number of moles of the base ne volume ye base uyayazi kusho ukuthi ungathola bani I concentration ye base. So when you do that, then you know no titration calculation will give you what? Will give you a hard time. I said in this sort of from this one so that we understand lento esikhuluma ngayo. Right. Example 80, we have 82 centimeter cube. So 82 cubic centimeter of what? Of HCl, right? Of concentration, basniga concentration, the concentration is 0.2 mole per decimeter cube. Any other unit learners kungabo capital letter M. Capital letter M now umele mole per decimeter cube as a unit. Molarity. So you have that one. They say is required. It is required to neutralize 60 centimeter cube of what? Of barium hydroxide. Of unknown concentration. Concentration as yes. Unknown concentration. So kutiwa calculate what? Calculate a concentration. Calculate the concentration gabani barium hydroxide. Right? So what do we know from equation, from the statement? From the statement sinobani sine volume ye acid, that is 82 centimeter cube. Sinani sine concentration ye acid, that is 0.2 mole per decimeter cube. Sinani 40 sine volume ye base, that is 60 centimeter cube. And then kutiwa calculate a concentration ye base, right? So what is the main thing? Principal ini a balance equation. The balance equation is over no HCl or reactor nani no barium hydroxide. Kuba go reactor no barium hydroxide. So kipela utu barium chloride plus what? Plus H2O. Mese equation ti I balance by balancing that one. So tolu 2 ngala. Right? So the ratio between HCl no barium hydroxide is 2:1. Right? So if formula yetu izotini Na over Nb is equal to CaVa over CbVb. So in that case, what do we have? Na siyamazi nanti it's 2 over 1. Ngoba the ratio is to 1. It's fagu 1 ngala. Then concentration siyayazi ye acid is 0.2. Volume siyayazi singa divide kube 0.082. Then concentration ye base yona sifunayo times volume ye base 0.082. 0006. Masenza kanje siyakwazi ukuthola bani i-concentration ye-base. So that's how you do what the calculation. Ngiyathemba bafundi ukuthi sizakele, then sobonana futhi next week for another topic. Siyabonga for today.
Siyathemba nifunde kahle nasithokozela isifundo sethu sanamhlanje. Enisethulelwe ngezilokotho ezinhle Ithala libambisene neGo Digital SA Foundation. Thamelani ke futhi esilandelayo ngesikhathi sifanayo. Ningakhohlwa ukumema nabanye abafundi bebanga le-12 ukuze nabo basizakale kulolu hlelo. Uma ninemibuzo noma nifisa ukuxhumana nathi, ningasithinta ngokufaka imibuzo yenu kwinombolo yethu ye-WhatsApp ethi 068 151 1072. Mfundi, ungakhohlwa ukubhala isifundo obuza ngaso ngaphambi kokubhala umbuzo wakho. Angiyiphinde inamba yethu 068 151 1072. Siyabonga.